Welcome students. Today we will start with schema definitions for type declarations in Z specification language. So first of all we will start with set type declarations. So very first is a variable of a set type is itself a set and is used to represent collections such as class of students. So we are starting with an example of a class of students for making a clear understanding about set types. So set types can be represented as, first is, for example, here is student. Student is basically the set of all the students. Subject is another set type that represents the set of all subjects. Further, we may define enrolled followed by F and student. So what it represents is that enrolled is a finite set of set type student. So here capital F represents the finite. Finite set is that particular set whose elements are countable, and similarly we have defined another finite set as access codes that belongs to the set type subject. So access code is the finite set of subject. For example, the enrolled set may be something like that: Raj, Medha, Tarun, and an example of access codes is formal methods, deep learning, and data mining. So we will try to understand with the help of an example for schema declarations with respect to user defined data types. So firstly we set an example here that students may join the Z class providing the class is not full. Those who successfully complete all the assignments may leave that particular class with the certificate. So here we are not concerned with the details such as student name, their date of birth, etc. So that's why we are only dealing with the basic data type as simple student. So there exists also a limit to the number of students who can join the class. So for that we define a variable as the max class size, and the limit of that is the 20. That means the maximum number of students that can join the Z class is equals to 20. Then we model a class system as the two finite set of students as enrolled and passed. So on the right hand side of this particular screen, you can see this particular schema as class. So this is my set type declaration student. This is a max class size variable whose limit is up to 20 number of students I can include in this particular class. And this is my class, and there are the two finite sets. One is enrolled, second is passed. Both belongs to the set type student. And basically this is now these all are set type declarations that also we have covered in our previous session, that above this particular vertical line these are called as the set type declarations, and below this particular vertical line we define some data invariant condition or predicates. So here the schema is named as class. It consists of the two finite sets of student as enrolled and passed. It has a precondition that is equals to number of enrolled student. This hash represents the cardinality. That is, the number of enrolled students should always be less than equals to the max class size. So the limit of the max class size is 20. That means I can only include 20 students in this particular class. And another finite set is passed. That should always be the subset of my enrolled. Further, before working with this particular class schema, we have to initialize this particular class. So to initialize this particular class schema, we make use of another schema, as you can see here on the right hand side of this particular screen at bottom. You can see here I am writing here init class. So init class represents the initialized class, and it includes the first line of this particular schema is class. You can see here that we have declared earlier. So the first line class above this particular dividing line in a schema, that is this particular vertical line in this particular schema init class, include all the variables and the predicates defined in schema class. So it means that it include all these particular finite sets inside this. Enrolled is also include. Second finite set is passed is also included, as well as this particular data invariant conditions are also present in this particular schema init class, and we initialize this particular these particular finite sets with 5. That means there is no element initially present in this particular in these particular finite sets. That is, one is enrolled, second is passed. So initially there are no enrolled students and no pass students has passed. That is, enrolled is equals to the 5. 5 represents my null set, and passed is equals to also equals to 5. So now a student may join a class if class is not already full and the student has not already enrolled. So these are basically the preconditions of my this particular schema, that is enroll OK schema. So I have created an schema here on the right hand side of this particular screen, that is basically enroll OK. And in our previous session we also discussed this particular delta. That means whenever we want to change the system state variables, then we make use of this particular delta sign, as well as this all the things I already discussed with you, that above this particular vertical line, this is these are called as the declarations. Before this particular vertical line, these are called as the conditions, right, and operations that we want to perform. So in this particular enrolled schema, a student may join a class if the class is not already full and the student has not already enrolled. So a new student cannot have passed all his assignment. Okay. So the question mark here, you can see in this particular second line of the declaration, there is some student, then a question mark, then colon, then this is the set type declaration. So this particular student followed by a question mark means that input. It means that I want to input this particular student in my class, or I want to allow this particular student in my class. So if I want to allow this particular student in my class, first of all, I have to check that particular student should be an element of your set type declaration. So after that, my first precondition is that hash enrolled should be less than max class size. So there is a relative comparison, that is, number of enrolled students should always be less than max class size. Then I can only include a new student. So it means that when we are talking of this, if this precondition is not satisfied, then I cannot input this particular new student, that is student question mark. But if this condition is true, then I will check another precondition, that student question mark should not belong to enroll. That means that the student that I want to input should not already belongs to the enrolled class. If it is already belongs to the enrolled class, then there is no meaning to include that student again. So it means that these are basically my two preconditions. One is in hash enrolled less than max class size, and second is the student question mark should not belongs to enrolled. And if these both preconditions will get satisfied, then I will perform this particular operation, that enrolled dash is equals to enrolled union student input, that is question mark. It means this particular student will get enrolled in my Z class now, if and only if these particular two preconditions, that is enrolled is less than number of enrolled is less than max class size, and student input does not belongs to the set of enrolled, and my pass dash will remains as equal to pass, because that is a new student has not submitted his or her assignments till now, so there is no change in the pass set. That's why pass dash is equals to pass. So further, after all this, we will design a new schema, that is called as the complete OK schema. In complete OK schema, an existing student is transferred to the past student based on the set of the following preconditions. So the very first precondition is that student that I want to input that should belong to the set of enrolled students. So student question mark should belongs to the set of enrolled students. This is my first precondition. The secondly, input student should not already be in the pass set, because I am now dealing with the complete OK schema, that I want to transfer a student to the pass set on the basis of these preconditions. Finally, if the student has passed all exams, then student will be transferred to the pass set, and the pass set has been updated as pass dash equals to passed union student question mark. So this is all about complete OK schema. Next is the last schema is leave with certificate OK schema. So in this schema, only those existing students who have passed may leave with the certificate. So the precondition in this particular case is that student should belong to the set of passed. So if you belong to the set of passed, then enrolled dash will becomes equals to enrolled minus student. That means that a student will get removed from my enrolled set, as well as pass dash equals to passed minus student question mark. That means that particular student who have completed all his assignments will be removed from my past finite set, and my finite set will get updated as pass dash equals to passed minus student question mark. So this is a summary of all the preconditions for the success of all the schemas. So we have represented three schemas in this particular case. One is enroll OK, second is complete OK, third one is leave with certificate. The very first precondition for the success of the first schema is that the cardinality of the enrolled should always be less than max class size. That is, the number of students in enrolled set are less than your max class size. And second precondition is that the student that you want to input should not belongs to enrolled. Similarly, for the complete OK, the very first precondition for the success is that it should belongs to the set of enrolled, and the second precondition is that student should not belongs to the pass set. And the leave with certificate schema consists of the precondition for the success as student question mark should belong to the set of passed. So this is all about the set type declarations with the help of an example. Thank you.